guys. We're on the home run. How are we feeling? Full of energy. Yay! Brilliant. Oh, do I have a clicker? No, doesn't matter. So what? I'm supposed to go to 1:30, but I'm 9 minutes late, so say 25 minutes to do a 30-minute talk that I wrote an hour ago. Excellent. So you may have noticed that we're doing, we've actually done like a whole product life cycle. So we started with kind of PCB design, soldering, case testing, and now we're talking about deployment. So look, wasn't that clever of us? That's how the week was arranged. So we're going to talk a bit about deployment. I'm sorry if you were here last year. It's the same talk. So you can go to sleep. So just a bit about me and my past projects. So I create a lot of fun projects on the side for Element 14 Presents, their YouTube channel. And so these are some of the projects I've done. When I finished my PhD, Joe, my supervisor, got all the people together and my husband and bought me Barak Door in Lego. Isn't that amazing? And I hacked it with a camera and a Raspberry Pi and some motors. And as you walk in the room, it follows you. So the eye goes... and it follows you around the room. And that's on YouTube if you want to watch the video. This is a moon. So you enter the date, and it spins, and it shows you what the moon was doing on that day. So you can find out on the day you were born, was it a half moon, a full moon? These two, what a point. The running men and the ladder are connected to Strava. So me and my brother, we run a lot. My husband, that was us running against each other. The first person to 100 kilometers, their little man would run. And the lights, we were trying to run to the moon, but we realized the moon is too far away. So we ran to the ISS space station. Again, another Lego project. And yeah, they're just fun projects that I make, a lot of light space projects. And it's kind of very makery, yeah? So like maker projects. And I would say that's a great place to start. If you're a total beginner, have a look at maker projects, because they generally start with a device. So we've seen some devices this week, and you have a microbit now as part of your solder bit. So you can always unscrew that and use that in other projects. So stop making tips to get started is find a device. So there's loads of devices out there, Raspberry Pi, Arduino, like some ESP32s, lots of WeMOS. Learn how to use it. Find an accessory. Learn how to use it. There's loads of guides. A lot of this is based for children as well, so it should be easy to follow along. Find a cool project and keep that enthusiasm. You know, when you look at something going, oh, that's cool, you know, that Barak Door thing. Wouldn't it be cooler if, you know, bring that enthusiasm to these projects and you will learn as you go. I was lucky when I was doing this, Twitter wasn't a hellhole, and I was able to share on Twitter, and I made like this really lovely community of makers. We all like encouraged each other. There's some like small bits like Blue Sky and Mastodon. I wouldn't say they're as big as Twitter, but it'd be good if they were, you know. So the projects I've worked on in the past, and how I use the project is I want to learn something new. So I didn't know anything about ESP32, so I decided to use it in my face mask project. So that's Bluetoothed to my phone, and as I speak into my phone, it would transcribe across my face what I was saying. So I learned how to do Bluetooth through that project. I hate Arduino. I hate it so much. But it's just the IDE, and I hate C, which Joe teaches. And so I forced myself to use an Arduino in a project so I could learn how to use Arduino better, and that was what the moon was. And the Raspberry Pi 5, which I didn't own, so for the tracking thing, it's a lot faster for computer vision software, so I use that in that project. So yeah, when you're doing your own projects, like have fun, find an existing tool, know when to listen to feedback. So if you're sharing this on the internet, there's a lot of people out there who want to tell you how you should have done it, which is not always very helpful. If I could remove the word just from the world, why didn't you just add this? And you're like, what? What does that mean? So it's okay to do things in a simple way when you're starting off. And it's okay to ignore experts, because they're experts. You know, you're not. And that's why I say for beginner as a maker. So I'm going to talk about two big projects that I worked on. This is a personal project called Cubert. It's an 8x8x8 cube of RGB lights. How many lights is that? I'm too much of a teacher here. Do some maths, somebody. 511? 12, thank you. Okay. They're all sitting underneath a ping pong ball. So there's 8 rows, 8 columns, and 8 deep, and they all have an individually controllable LED. Oh, yes, I have a video. Do I have a video? I did have a video. Let's see. Oh, yes. Aha. Close that one. Is it running? Is it running? Is it run? It's a metre high. And I made this at home for fun. Someone else had done it, but they'd done it in solid columns. We built it in his basement and could never get it out of his basement. So I wanted to build something that you could bring around places and show off to people. It's controlled by a microbit. So there's a microbit controlling all 512 LEDs individually. And this is just an animation. That's what most people tend to do with these cubes. But I made mine interactive. You could play Snake on it, but in 3D. So you could go into the cube, left, right, up, down, which is great because people were like, what? And it was fantastic. I brought it everywhere because I could. It fit in the boot of my husband's car. And the base was too big, so I built the base in 2 sections. And these are all the places that I brought it. So the BBC invited me to their internal tech day in Salford. I brought it to Pi Wars in Cambridge, Newcastle. I even brought it home to Dublin. That's where one of those photos, coolest projects. I should have charged them. They keep using this photo in a lot of their materials because it's such a great photo. And yeah, Microbit Live as well. And yeah, I learned a lot of lessons from this cube. So I built it on my kitchen table with 2 toddlers. And I bought like galvanized steel wire, which you can't solder onto. So you have to add flux, and flux is very toxic. And this is the kitchen table. So my setup was a really long time, like clear the dishes, put the flux down, solder for 4 hours, put the flux away, put the dishes back on, and disinfect in between. It's a lot of power, 512 LEDs. I basically had a PC power supply. My husband connected it wrong, and we got the black smoke pumping out of it. The galvanized steel wire was a nightmare. It came in reels like this, so we had to straighten it with a drill. And yeah, I shared a lot of my successes and my failures on Twitter, and I got a huge amount of following. People just loved the project, and they encouraged me. And it kept me going, really, because it took 6 months to build this in the evenings. And then the second version, Pimoroni, gave me the boards. So we made the boards ourselves. With the second version, Pimoroni, the company, loved it so much that they actually supported us. So they were the lessons learned in a small, individual, personal project. Then, just before COVID, we started a project with Blackpool Illuminations. Who knows Blackpool Illuminations? Oh no, what? Okay. Blackpool is a town just south of here. It has this big tower. It kind of looks like the Eiffel Tower. And it's a seaside town. So during the seaside, they have tourists. In the summertime, but in winter, they decided we're going to bring back those tourists and have a light show. We're going to have this huge light show along the seaside, along the prom. And they decided this like 100 years ago. It's one of the oldest light shows in the world. They have 10 kilometers of these lights going along the promenade, down their piers. It costs over £2 million to run, but it brings in millions of visitors. And this is a deprived seaside town, and it brings in so much money and so many people throughout the winter, throughout the rain and the snow. It runs from September to January, and it's run by 20 staff. Like, very, very few people run this project. It's run by the council. And it's a very inspiring project, I feel. These lights, you know, they might buy the lights physically from China, but everything is built in Blackpool. They have a factory by the warehouse, so it's built by Blackpool people for Blackpool people. I think it's a very inspiring inspiring project that maybe not a lot of people know about. That it's built by people in Blackpool. So there was a bid to create something interactive. The problem with Blackpool is that what people do is they drive along this road, they see the lights, oh, they're shining, and they drive away. They never get out of their cars. So they're trying to encourage people to get out of their cars, to spend money in the town, spend time in the town. So they wanted to make an interactive display. So we won the bid alongside a local boy called Jack Irving. He was born and raised in Blackpool, now lives in London, and he's a fashion designer. This was one of his creations, 2 of his creations for Lady Gaga. So that luminous dress and that crazy fish thing. He's obsessed with fish I don't know why. Maybe because he grew up in Blackpool. And this is what's his name? What's Lawrence's role in the Illuminations? He's like the creative director. Who knows Lawrence Llewellyn-Bowen? He's a UK celebrity, very flamboyant guy. You would never think Blackpool would be where he's based, but lovely guy. And the three of us came together to build Odyssey. Let's see if I can get Odyssey to run. So I'll just show you what it is. I won't play the whole video. So it's like 6 goddesses on the road, on the prom. They're 9 meters, so bigger than this building, about the same size as this building. And they're projecting a path onto the ground. So they each have a projector inside them. Let's see. It's in front of the tower, and they project onto the tower as well. You can see the fish going across the tower. You can see. Don't know if this speeds up at some point. Wait. Has lasers. But yeah, they got in a lot of trouble for those lasers. They interfere with traffic control. So you can see the path there. So it's a projected path, 6 meters long, right in front of the tower on the prom, so people can walk up and down this path. There's 6 projectors, and there's 6 cameras, and the cameras are detecting people on the path. And as the people walk along, certain fish will follow them. Certain fish will separate and move away from them. Certain fish will come up from below and try to eat them. So it's kind of like an interactive fish display. And it was a huge project, like 6 of them. They're all like 8 to 9 meters tall each, with all those lights and electronics. So I'll split into 3 sections and then go on to deployment. Before I talk about Odyssey, it's kind of like why. So we started this just before COVID, but we got delayed, and then we ended up starting it while I was doing my PhD. This has nothing to do with my PhD. Absolutely nothing. I spent the first 9 months of my PhD doing this project. I wasn't paid for it. The university wasn't paid for it. And it's like, it's computer vision. I'll show you in a second, but it's computer vision technology. I didn't know computer vision before this project started. I had no interest in computer vision. Obviously, I love shiny lights, which is why we went for the project. But when you're on a project, you have to kind of always remind yourself, why? Why are you doing this? And it's because of Blackpool. It's an area of high deprivation. It's a local area where children aren't choosing STEM subjects. They aren't finishing school. And it's an area that has this amazing illuminations, and it's losing that connection between, look at this fantastic thing that's created by technology in your town that you could be a part of, that you could see, you could understand, that you could do this. And a lot of people don't see computer science as creative. And it is computer science. The whole illuminations is very technical, and we just want people to know that. So that's why we want to be involved. We want to create connections with illuminations, connections with Blackpool, and we saw this as a way of doing it. So we split into 3 areas that happened in parallel. So there's design and manufacturing. So they have a design team in the illuminations they had a whole CAD team of designing the structures. These are big, massive concrete bases, which are about this high, that people love to climb on, but they're not meant to, because the whole thing needs to be weighted down. It takes like 2 lorries to transport them to the prom from the factory, which isn't far. Then each goddess, so there are 3 separate goddesses, 3 separate designs. They all have LEDs going through them, and then they double that up. This is I don't know, he named them. I can't remember the names of them. I think that was Athena in the middle. Yeah. That gives you an idea of the scale of what they were aiming for. So they took months of designing that, of like structuring that, of how they were going to make it. And then manufacturing team took over. So this is in Illuminations by the airport, their factory is. So you used to hand carve polystyrene blocks. Imagine a polystyrene block this big, and they would hand carve it into a shape. But that year they bought this electronic arm, this moving arm, and they send the 3D printed files to it, and it would mold the polystyrene into a shape, create a lot of snow, And then they would put the fiberglass on top of that mold. So this is how they make the structures, and this is how they were making them for years. Just they moved from hand carving to the thing, because hand carving would take weeks, while this thing took like a day to finish one sculpture. And you can use multiple molds for, you can use the mold multiple times, and that's the fiberglass of the structure. And then they would paint that. And this is me standing next to one of the first goddesses that were complete. So you can see that's their manufacturing process. And we're not involved in that, but but think of it as the case for our project. Our projector and our camera went inside this. So it was very important that we talk to the people who are manufacturing and designing this. They had their own manufacturing timetable, project management, managers, which is all really important, and sharing that information is really important. One thing that did go wrong, it's nice to mention the things that go wrong. The project was a success, I have to say, but the projector had to go in the chest of the goddess, and they brought this out like in 4 lorries. It took 3 days to assemble, and they're like, oh, hang on, where's the hole for the projector? Where does the projector see out of? So we had to drill. You can see the seam kind of there, but they had the guy on a ladder on a cherry picker, yeah, at 9 p.m. at night in the rain. He wasn't very happy, Simon. He had to drill the hole for the projector to go through, because we were there ready to test the projector. So that's very important to talk to your other teams. Even if, I'm not building this, I have no idea how to build this, but my thing is going inside that. So communication with teams is very important. And this is our section. So we had 6 cameras, 6 projectors. Each camera overlapped the next camera. So each projector overlapped the next projector, so we had to calibrate the projectors to align with each other. In the dark at 4 meters high. So we started with a proof of concept. We used a NVIDIA Jetson in my kitchen. That's me, in the kitchen. And we're just trying to figure out, because we didn't want a PC in every goddess. So we wanted a small microcontroller computer kind of thing. We're just looking for speed, so I was doing these kind of motions to make sure that it could detect me. Yeah? It didn't need to detect my elbows and my wrists. It just needed to detect me. But we were looking for speed. We talked about adding, when people lift their left hand, that the floor might go blue. We talked about adding those kind of interactions. We didn't, but maybe we could in the future. This is my front garden. This is my husband. So this is about 3 meters sticking out the front my son's bedroom window. So we built prototypes, but we didn't build PCB prototypes. We stuck it to a piece of wood, and a tripod stuck out the front garden to test that it would work at that height. You can see the NVIDIA logo. That's me. And that's going out the back garden, which is a bit higher than the front garden, in the dark. So we could test whether it would work in the dark. Then we need an infrared camera. And these kind of things. There's another testing rig. That camera is 8,000 pounds. Projector is about this big. It's about 8,000 pounds. Let's strap it to a piece of wood with some foam and lift it 4 meters in the air. Yes! What could go wrong? Nothing did go wrong. They were confident on their strap. Other challenges we had is, we needed infrared cameras, but the factory that they hold the illuminations in has skylights. Why does an illumination factory have skylights with no curtains and no way of closing those lights? In the middle of the day, it's just so bright. So I had to put in these sheets to try and see. There, you can see the projector there on a proper stand. Yeah? See how high up it is. But these sheets did nothing. They didn't help. So I had to try and scan. These are called Chariku codes, like QR codes for mapping. And I couldn't see them with my cameras. So, this is... So lessons learned from electronic and software is that ad hoc solutions have their place. You might not need a PCB as your first prototype. It could be a controller stuck to a piece of wood. Have your test suite as close as possible to the real-world situation. So we needed something at 4 meters. We needed it at this angle, in this darkness, at that height. So every single part of the real world that your device is going to be in, if it's going to be exposed to the elements, you need to put it in the elements. You need to put it in a puddle for 6 weeks to make sure that it runs and it works. I got loads of advice from people, as always, but some of it was helpful. So we were sticking it out with a broom initially, but someone said, why don't you just connect it to a tripod? I'm like, oh, genius, because tripods can be extended. So it's nice to share your projects with people because it keeps them enthusiastic. Like, this is cool, this is fun. It's maybe not fun at 9 o'clock at night on a Friday night because you have to do it when it's dark, but it's fun to other people. And you share your enthusiasm to people, they'll share some ideas that maybe you've not considered. So they're the lessons learned from that. What do I have time? Oh, got 5 minutes. The content was another, so the fish themselves, they had a graphics team working on the fish. The graphics team, it looks cool on their computer, on their screen. That looks amazing. What does it look like in the dark on a grey floor? That wasn't their test, that was my test. So understanding parts of the project that are yours, because I thought I don't have to worry about the content, someone else is going to create the fish. But this is the ground that we had to display on. It's grey. It's got manholes. It's bumpy. It's textured. While the floor I was testing on was smooth and straight and dirty. The seagull. Luckily, the camera didn't detect seagulls because I thought that might be a problem. We couldn't deploy. So you can't always deploy in the situations that you want to because this is a public path and it was a top secret project. So we couldn't actually announce it until it was up and ready. Obviously, they had to build it for 3 days. But I couldn't talk about it, I couldn't publish photos about it, and I couldn't test it because of that reason. So lessons learned from that is test early as much as you can. Get on that prom with your cherry picker, with your projector, with the strap. Build as much as you can before you deploy because you don't want to be drilling on the prom. And do some. Oh yeah, this is a Raspberry Pi camera in a quite a nice waterproof case. What's wrong with that? What could go wrong? What could possibly go wrong with these cameras? Steve knows. Do you know? No, you don't know. What do you think is wrong?
I'm guessing there's going to be seagulls.
Seagulls?
And they're going to crap on
Seagulls were a factor.
Oh, yeah, like poo, yeah. Yeah, seagull poo, that had to be washed, yeah. And it's 4 meters in the air, so a guy with a cherry picker had to come out and clean all the cameras. Condensation wasn't a problem, no, condensation. Any other ideas? Anyone used a Raspberry Pi camera before? Cable, yes! Those beep cables. Where, ask Joe about those cables. 2 a.m. on a Thursday night.
Sub-zero temperatures.
Very cold. December, standing on a ladder, trying to get that cable back into that.
I think getting it the wrong way around.
Getting it the wrong way around, yeah.
I did more than once.
We never thought of that. We were testing indoors. The thing was 4 meters away. It always worked. But installing it, because you install it once, right, on the ground, and you lift it up. But in this case, we had to install it in the air.
Yeah, I did remember cursing 4 meters up the ladder, thinking, if I ever meet the person who built,
yeah,
that Raspberry Pi
connector,
the camera into it, this occurred to me, it was here yesterday.
It was Pete. It was Pete.
I could have got my vengeance, but missed opportunity.
Another thing is to do valid testing. I used to be a software test engineer for Microsoft, and your tests are insane. They're so detailed. There's so much detail in it that you get completely bored testing. And this was a fun test, but it wasn't really a valid test. So I had the word Lorraine is the best going across all 6 projectors. So I was trying to line up, this projector with that projector, so you can see the N isn't quite lined up. But it kind of looks okay, but in a bigger picture, it's not okay. The overlap is really obvious. So that wasn't a valid test. I went with the QR codes in the end. But yeah, don't have fun with your testing. Take testing seriously. We had a lot of success then. So this was the Charaku, increasing the brightness, putting those sheets up. This is the, where is it? Oh, I didn't. 10 p.m. on the 21st of August. This is Sam. He was a third-year undergraduate. So it's detected him, and the animation is following him. So there's 6 projectors above us, and it looks really cool. And it works. And then the animation changes to a different thing, so it only works for about 5 seconds. They wanted it to be very subtle. And they only wanted it to work for 1 in 5 people, which is like, no, that means it looks like it's broken. But it worked. So yeah, the lesson learned overall is talk to all your teammates. You might not be designing the case, but you definitely need to talk to people who are designing the case. I don't know about compatibility. We very unfortunately, we started off with NVIDIA Jetsons, 6 of them. We started off with 1, and we thought, okay, we'll just buy the new 5. Couldn't buy them. Complete chip shortage. So as soon as you decide you're going to use a technology, just buy it. Testing is worth its weight in gold. Do as much test as you can, as close to live deployment when you can. Rain, wind, sleet, small children, seagulls, all these things matter to our thing. Yeah. And remember your motivation at 2 a.m. up a ladder. Why am I doing this? It's good to have early wins as well, you know, like having... What did I do? I don't know why I crashed the whole presentation then. Having early wins, having early kind of fun stuff to remember when you're struggling with testing is like, this looks cool. This is going to look cool to everybody else. I've been doing this for 6 months. It doesn't look cool to me anymore. But actually, you know, keep that motivation. It's like, this is going to inspire so many children to wonder, how is this done? You know, this is cool. Technology can be cool. And that was the goal of the project. And it's still running. It runs in October. If you want to go down to Blackpool, you can see it. We've started a new project this year, which has created a yearly relationship with Blackpool, that they're just going to hire one of our interns to run projects every year, which is, can't tell you what it is, because it's top secret, but you might see some things, I can't say anything, on the prom in September that belong to Lancaster University. That's it. I said, yeah, 11:35. Any questions about deployment, testing, Blackpool, lights? Yes.
Computer vision.
Yeah.
So libraries to use, Python or OpenCV?
It was OpenCV, which is usually written in C. So a lot of the guides are in C, but it does have a Python library to it. But I found it really hard to debug a lot of the things because all the solutions were in C. I use a PostNet model. So we did test different models as well because we wanted speed and darkness. And the models don't tell you what they're good for. You know, like, we're good for detecting dogs. I'm like, oh, I want people. Like, yeah, so we did a couple of testing with a few of the models. But it was Python because the final thing we ran it on was a Raspberry Pi. Yeah.
Oh, you ran it on it?
Yeah, so we gave up on NVIDIA because we couldn't buy them. So halfway through the project, we completely changed all the technology to Raspberry Pis, 6 Raspberry Pis, using PostNet model and OpenCV.
You had to use it, you hadn't done, like, you hadn't used CV before?
No, never. Never used it before. So, yeah, I kind of learned the idea of it in C, because there's a lot of guides of it in C, but then I deployed it in Python, because that was my language that I was better at. And it was me debugging it all the time, so it was better to do in a language that I was comfortable with. Yeah? I don't think we haven't got any questions. Oh, wait.
Got you.
Have we got a question?
Yeah, yep.
Cool.
Okay, that. Can't do this.
Just a really quick question. So how many people could walk on that thing at one time?
It was 6 meters long, so as many as could fit in it. It could detect 6 people per camera.
Okay.
So it could detect 36 people.
Okay. Wow. Okay. Thank you.
Yeah. Hi, thank you for your presentation. So my PhD is also about computer vision using Raspberry Pi too. So I'm curious because it's a light installation, so it would, like most people would go at night, right?
Yes.
So how do you how do you detect people at night?
Yeah, so we initially we were like, oh, we need infrared cameras, or we need infrared lights going around the side of the thing. So that's what the purple light was. So that's the camera looking in infrared. But then when they started building the structures, we realized, which is again why you should talk to your design team, this is full of LEDs. See the little holes all the way down it? Where's the mouse? It's got like thousands of LEDs in it. So the structures themselves lit up the path so we could see the people. And we made sure that the angle was right, because there's no point in seeing the tops of heads. So we made sure like the angle and the height. So the projector was in the chest, but the camera was in the belly. So that it was at a better angle for seeing people, seeing their bodies, rather than just tops of head. That was really important, obviously. Yeah.
Thank you.
Thanks.
Yeah, it was around 2.5 meters up. So yeah, low was actually about there. You know, it's quite elevated, but yeah, it did make a difference.
The camera, yeah.
Any more questions? Yeah.
Yep.
You mentioned about getting real-world tests.
Yeah.
But because this was confidential,
yes,
were you even able to get those tests? Like, looking back, is there something different that you would have done with the testing, or is it just that it was always going to be tough because you would deploy and...
Yeah, like what was secret was the goddess. So I could put a camera 4 meters in the air anywhere. So we actually took over one of the lecture theatres for the summer, and we put the projectors up there, and we put so we just had the projector and the camera together. So the secret bit was the design and the fact that it was a goddess and that it was interactive. So we were able to do a lot of the testing. But like if you're standing on Blackpool Prom, people are walking past going, "What are you doing?" And you're like, "Nothing." And especially like, "What are you doing with that camera?" Nothing. It's just a test.
Move along. Nothing here to see.
None of your business.
Yeah, we did set up. You mentioned earlier it was during COVID times, wasn't it?
Oh, yeah.
Yeah, during COVID, and we actually one of the view benefits of COVID is that all the students were remote. Yeah. So we took over one of the lecture theatres in the university, the George Fox complex, and we just owned it for 2 months, treated it like a huge lab, and we set up a 50% scale model of the whole thing, and we kind of just did it behind literally closed doors because there's COVID. So yeah, in some ways we were just lucky in that respect.
We take last question, and the first speaker is up. Who's up first? Presentations.
How would you recommend someone to learn computer vision from scratch?
Who's talking to me? Oh, hi. I couldn't see you. Yeah, so OpenCV is like the standard. It's the best library. They have a whole website. Like I said earlier, it's based in C, the C programming language. So a lot of their guides are in C, but a lot of their guides are just theory, which is quite nice. It's hard though. It's very technical. It's very mathematical. I couldn't explain to you. I can't even remember the word for it. We're trying to calibrate 2 grids together. Homography matrices. So I use them when you need to calibrate a projector and a camera because they're in different views. Use a homography matrix, and I did that for the Barrack Door project. So I used it again just to remind myself. But I could not explain the maths behind that. But I don't need to, because I know how to get it working, which I think a lot of computer science sometimes, do you need to know how a stack works, Joe? You don't need to know what a heap is. It's good. It's good if you're a nerd and you really, really want to go deep into the code, but you don't always need to know how it works, like the really detailed stuff of how it works, just that how you get it to work can be enough. Yeah.
And there's understanding the limitations of what the software does, of course.
Yes, yeah.
All right, thank you. So round of applause for Lorraine. Great talk. Thank you.